Hello everyone, welcome to our channel. In this video, we are going to see class 10, chapter 2 Polynomials, exercise 2.2 introduction. So in this introduction video, we are going to see relationship between the zeros and the coefficient of a polynomial. So what are the coefficients of a polynomial? First, we know that a quadratic polynomial can be written in the form ax square plus bx plus c. This is equal to p of x. So the coefficients of a polynomial is a is the coefficient of x square, b is the coefficient of x, and c is the constant term. So here we are going to see alpha and beta. So alpha and beta are the zeros of the polynomial p of x, or the zeros of the polynomial p of x, and we can say x minus alpha and x minus beta are the factors of the polynomial p of x. So ax square plus bx plus c can be written as k into x minus alpha into x minus beta, where k is the constant. Any constant value. So when we multiply this, that is when I multiply x with x and with beta, and the next term I will multiply is minus alpha with x and minus alpha with minus beta, I will be getting a quadratic equation, that is k into x square minus alpha plus beta into x plus alpha into beta. So when they ask us to find the relationship between the zero and the coefficient of a polynomial, we have to use certain conditions, that is alpha plus beta, that is these are the sum of the zeros. Sum of the zeros equal to minus b by a. b is the coefficient of x and a is the coefficient of x square, and we have to use this relationship or the condition, and we have to verify that both the zeros, sum of the zeros and the coefficient are equal, that is the left hand side and the right hand side are equal. Next is product of the zeros. So product of the zeros is alpha into beta, and this is equal to c by a, and this is a relationship or the condition you should remember, and you should memorize these both when solving the sums, and this is applied only for the quadratic equations, that is only for the quadratic polynomials we apply these both. For the cubic polynomial we will be having other conditions. So in the cubic polynomial we will be having 3 zeros and we will be applying different conditions. So when they asked us to verify the relationship between the zero and the coefficient of a polynomial, we have to use these two conditions and verify. The second part is when they have given the sum and the product of the zeros, that is when they have given, I am giving an example. For an example, they have given the sum of the zeros as minus 3 and product of the zeros as 4. So I need to form the polynomial. So that time I can use this condition or this equation. So that how I will apply is k into x square minus alpha plus beta into x plus alpha into beta. So sum of the zeros, this means alpha plus beta is equal to minus 3. So I need to put minus 3 in place of alpha plus beta. So k into x square, I already have a minus sign in the formula, minus alpha plus beta is minus 3 into x plus alpha into beta is 4. So I will be getting k into x square plus 3x plus 4. Here minus into minus is plus, 3 into x is 3x plus 4. So the required quadratic polynomial will be of the form x square plus 3x plus 4. And with these zeros, that is, these are the sum of the zeros and the product of the zeros. If they have given only the zeros and they asked us to find the quadratic polynomial, we have to first find the sum of the zeros, product of the zeros, and then apply in this condition. So we have to read the question thoroughly and properly, that we have to check whether they have asked for sum of the zeros or they have given the zeros. So if they have given only the zeros, we have to find the sum of the zeros and product of the zeros and then apply in the equation. If they have given the sum of the zeros itself, we can straight away apply in the equation. And this is for quadratic polynomial. So when they ask us to verify the relationship for a cubic polynomial, we have other conditions. That is, for the cubic polynomial, we will be having 3 zeros. So for cubic polynomial, alpha, beta and gamma are the 3 zeros of a cubic polynomial, and the standard form of the cubic polynomial will be ax cube plus bx square plus cx plus d, and this is the standard form of a cubic polynomial. And when they asked us to verify the relationship between the zeros and the coefficient of the polynomial for a cubic polynomial, we have to use these 3 conditions, that is alpha plus beta plus gamma is equal to minus b by a, and this is same as the sum of the zeros we did in the quadratic polynomial, that is sum of the zeros minus b by a. We have included the other zero gamma here. Similarly, for the product of the zeros, we got c by a. Here the product of the zeros will be alpha into beta plus beta into gamma plus gamma into alpha. This is equal to c by a. And the third one, so the cubic polynomial, we have 3. So alpha into beta into gamma, this will be equal to minus d by a. And we have to use these 3 conditions to verify the relationship for a cubic polynomial. In the next video, we will be covering the exercise 2.2 sums. Thank you.